On exercise 1, it says, we worked on equations of circles. Which of the following would represent the equation of the unit circle? Which one do you think? Which one do you think? Which one's the unit circle?
4.
No.
Nice.
Anybody else want to take a shot at it?
2. 3.
It's 3. Because this is a circle with radius 1, but it's not on the origin. It's centered at the point 1, 1 is the center. This is centered at the origin. That's what the unit circle is. So just draw your circle 3, because that's the answer, but then draw yourself a little unit circle so you remember, and you can refer back to it. Remember, it's going to be centered at the origin, so draw the center at the origin, and this point here is going to be 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. And the circle goes through all those points because the radius is 1. That's the unit meaning 1 circle. All right, let's go on to the next. Okay, now, we did special right triangles. Now, we're going to talk about 2 special right triangles. They're basically the 30-60 triangles and the 45-45 triangles we worked with, but with a hypotenuse of 1. So, this is one of them. Do you recall how to get from a leg to the hypotenuse on a 45-45-90 triangle, what we have to multiply by to get to the hypotenuse? Rad 2. So, if we're multiplying by rad 2 to get from the leg to the hypotenuse, how do we get from the hypotenuse to the leg? Yep, divide by square root of 2. So, we know that x is going to be equal to the hypotenuse divided by the square root of 2. Now, we can't write it that way. We have to get rid of the radical in the denominator. So, each of these legs is rad 2 over 2. Make sense? So this triangle is going to look like this. Rad 2 over 2, rad 2 over 2, and 1 for the hypotenuse. All right. Now, next one we're going to do is a 30, 60, 90, same length hypotenuse. So, can you remember how we got from the short side to the hypotenuse? Do you remember what we did to get from the short side to the hypotenuse in 30, 60, 90? Multiplied by 2. So what do you think the short side is here if the hypotenuse is 1?
No. If the hypotenuse is 1, then that would be
Come on, you
Come
got
on,
it.
Brendan.
Come on, you got it.
Come on, you're dividing by 2. So what's 1 divided by 2? Just a half. Right? Yeah. So this is when we're going to divide by 2, so this is 1/2. Now how about getting from the short side to the long leg? From the short leg.
multiplied.
By what?
Rad 2.
Rad 3.
No, that was the other one.
It's 36.
3069.
Right. So we multiplied by 2 to get to the hypotenuse. Long leg is radical 3. So this is going to be 1/2 times radical 3, which is radical 3 over 2. So there's the other triangle we're going to need today. So make sure you have that triangle copied down. So those are what you call the special right triangles, I call them, because we're using them on the unit circle. Not only are they 30, 60, 90, and 45, 45, 90, but they have something else special about them. They both have hypotenuses. 1. Okay? Okay, now comes the part where we get to use these triangles, and I put them both here. This says the diagram below represents a unit circle. Based on your work from the last 2 exercises, fill in the ordered pairs of each of the angles that are soon to be drawn in standard position. So the first thing I'm going to do is I'm going to go ahead and find this ordered pair. Now you'll notice on the unit circle, there's 90 degrees in between 0 and 90. But this only has 3 angles, 30, 45, and 60. That ought to ring a little bell and say, wait a second, I know my 45, 45, 90 triangles, and I know my 30, 60, 90 triangles. That's why these are the only ones you can do without a calculator and having an ugly decimal. So Let's do that 30 first. Now here's the way you do it. There's the two triangles. Okay? This is 30 degrees. So you say to yourself, okay, I got to use my 30-degree triangle, my triangle with a 30-degree angle in it. And here it is right here. What you have to do is imagine this triangle moved right in place of where the angle is. Now that that's the case, can you tell me what you think the x-coordinate is here? What do you think the x-coordinate is at that point? Rad 3 over 2. Because that long leg now becomes the x-coordinate when I move the triangle onto the unit circle. And then the y-coordinate is going to be a half. Does that make sense? Now, what you can do is, you can get the rest of the 30-degree angles with symmetry. You remember what symmetry is? You reflect over stuff and it's symmetrical about the origin or about the y-axis or the x-axis. So if I take this triangle here, and I flip it to the left, I can now use that over on this side of the unit circle. Everything just sort of switches. So I can get this point as well. That is going to be the x-coordinate. What's my x-coordinate at this point? My x-coordinate. Careful the positives and negatives. It's negative rad 3 over 2, right? Because the x-coordinate is on the left-hand side. It's to the left of the y-axis. So the triangle still has that length, radical 3 over 2, even though I got it superimposed. It's going to be negative rad 3 over 2. And my y-coordinate is still above the y-axis, above the x-axis, so that's going to be 1/2. Okay? So now what I want you to do is take a minute, and I want you to do the other the other angles that are 30 degrees, these two below the x-axis. Go ahead and give it a shot, and I'll get right back with you. So what did we get for this one, Brennan? What do you think? Brennan. How about this one? Okay, so what's the x-coordinate?
Negative.
Remember, you're taking this triangle. Or if you keep talking, I'm kicking you out. Just focus on the board. You don't need to be on other people's business. You're going to put that triangle right there, right? So you know the y-coordinate is the 1/2 side. You can tell that. So the y-coordinate is going to be negative 1/2. And the x-coordinate is going to be positive rad 3 over 2. See how I got that? So the x-coordinate is going to be positive rad 3 over 2 because it's to the right of the y-axis, but it's below the x, so it's negative 1/2. And you want to give a shot at that other one over here? What do you think this one is? I don't want to hear from Irvin. What's up? I can't hear you. They're both negative, but tell me what the coordinates are. And negative 1/2 x, because the x is to the left and the y is down. So you have to just be careful of the signs, but other than that, you can use that triangle. Does that make sense? Okay, now, let's go on and let's think about why is this thing doing that to me? There it is. So let me flip, left, right, and then we'll rotate. Now what we can do is, we can do the other angles that are in that triangle. What's the other angle besides the 30 in that triangle other than the 90? It's the 60. So we can do all the 60-degree angles as well. Here's how. I'm not going to use the triangle. I'm going to leave it to the side. I'm just going to sketch it. So here is a 60-degree angle. So I can take this triangle. I can make this, the hypotenuse is always going to be the one side. This is the long leg. So that's going to be rad 3 over 2. And this is the short leg, that's going to be 1/2. So the 60-degree angle has an x-coordinate of 1/2, because the short side is now the x-coordinate. and the y coordinate of rad 3 over 2. Okay? Now a little less help. I want to see you do this angle, and that angle. Get me the coordinates for all those. Go ahead and give it a shot. Now the best way, I'll do these in green, is to just redraw the triangle. You always know you're going to grab your point. You always know the hypotenuse is going to be 1. You look at the space in here. That space is 180 to 240. So that space is your 60 degrees. So that means the 60-degree angle goes here. So drop your perpendicular to the x-axis. This is your 60-degree angle, and right here it's got to be your 30, because that's your 90. Now we know across from the 60 is radical 3 over 2. So that's going to be your y-coordinate. But it's going to be negative because it's below the x-axis. Across from the 30 is a half. So that's going to be your x-coordinate, which is negative a half because it's to the left. And that's the way you work. And now you can just go ahead and flip that over the y-axis. You're going to get this one right here. So that one's going to be, what, positive 1/2, negative rad 3 over 2. And then this one over here is going to be negative 1/2, positive rad 3 over 2. Did you guys get those all right? Have any questions? Are we cool? We're good? Okay, now we're going to use the other triangle. See, there's only, let me mark them in. Let me mark them in, I guess blue. Yeah, blue, why not? Not red. There's all that's left are these right here. Okay, so you can take that 45, 45, 90 triangle with a hypotenuse of 1 and use that the same way you used the 30, 60, 90. It's actually a little easier because both sides are the same. You don't have to flip it as much. In other words, you can use this for that, and all the other quadrants are a little bit easier without the reflection. So this point right here, which is 45 degrees, that would be rad 2 over 2 would be x, rad 2 over 2 would be y. So this point is going to be positive rad 2 over 2 for x, positive rad 2 over 2 for y. So I'll let you guys go ahead and get 135, which is 180 minus 45. Then I'll let you get 180 plus 45, which is 225. And then 360 minus 45, which is 315. I'll let you fill in the blanks there. I'll go over them with you in 1 minute. Let's check our work. Now, you know they're all going to be rad 2 over 2 and rad 2 over 2 because they're 45-degree angles. So this one's going to have a negative x coordinate, negative rad 2 over 2, but a positive y. This one's going to have, both are going to be negative. And this one's going to be a positive x, and then negative y. Now the last points it asks you to fill in are this one, all the quadrants. So, now remember it's the unit circle. So how long is this line if it's on a unit circle?
0,1.
Close. How long is this line if it's on a unit circle? The radius is 1, right?
Yeah.
So think about that. Yeah, right. So this length right here is 1. So the x-coordinate is this length, so it's going to be 1, and the y-coordinate is 0. Same thing. Remember, this is a circle, and it's got a radius of 1. So that means this is a radius, so that length has got to be 1. So Burke, what's the x-coordinate right here? What's the x-coordinate right there? Come on.
I don't know.
This is like x and y. What's the x-coordinate there?
0.
So what's it going to be up there?
0.
Very good. And the y-coordinate?
0.
No. 1. Burke is depressed. Now, here, same length 1, but it's negative. So it's going to be negative 1 on x and 0 for y. And here, 0 for x -1 for y. So that's how you figure out those angles. You have every single angle on the unit circle now. Okay, what the x coordinates and y coordinates are. We're going to connect that more tomorrow. Now,
Oh, we're coming to school on Saturday.
I mean, whenever I say tomorrow on Friday, I mean Monday.
Yeah, but when you drop on
Here
Monday.
Monday.
Do you really?
Yeah.
Oh, man. Okay. So, to do these, I'll let you do these on your own in a second. But to do these, this says to do the basic thing, only now you have to draw it. So let me do one that's kind of like this one. Let's say negative, how about negative 210 degrees? As an example, I'll do negative 210 degrees. So what you have to do first is draw the angle in standard position. So you're going to do your terminal side, your initial side, and you're going to go to 210 degrees. So 90, 180, then another 30 degrees. Now, there's your angle right there. Oh, I said negative 210, sorry. Well, we'll make it positive 210. I went positive, so why not? So, what you're going to do from there is examine how much space is in here. This was 180, we went to 210, so that's got to be 30 degrees in there. So I know what triangle I'm using. Drop your perpendicular. 30 across from that is a half, but it's negative. This is going to be your 60. Across from that is going to be rad 3 over 2, but it's going to be negative. So the coordinates here are negative rad 3 over 2, negative 1/2. For each one of them, you have to draw a rotation diagram. So why don't you do pi over 3, and then I'll let you get to work on the set. Remember, you can convert it to degrees by multiplying by 180 over pi. Give that one a shot, and then you'll have listened to me enough. Okay, so for each one, you have to draw the rotation diagram. So your initial side, it's positive, so it's going to go up. And you're going to cross out the pi, then you're going to have 60 degrees. So we're going to sketch 60 degrees. So then you say, okay, I got a 60-degree angle here. I can use a 30, 60, 90. Drop your perpendicular, label your triangle. Hypotenuse is 1. Across from the 60 is rad 3 over 2. That's going to be your 30. Across from that is 1/2. So your coordinates are positive 1/2, positive rad 3 over 2 for y. We good? Cool. Questions? Mark? Uh-huh. You always drop the perpendicular to the x-axis. It's a good question. So for this one, you're going to go negative 120. It's going to be here. So there's your initial side, and drop the perpendicular to x. And you have to figure there's going to be 60 degrees of space in there. So use that 60-degree triangle. Okay? Cool? All right. Go ahead and get to work. Cool.